am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic Reflex Klystron. It is one of the microwave active device. And the need for Reflex Klystron is it is to be used in microwave electronics for generating and amplifying the microwave signals, which is in the range of 1 gigahertz to 40 gigahertz. It operations based on the principle of velocity modulation of an electron beam passing through a resonant cavity. So we call it as reflex klystron because the name reflex comes from the fact that a portion of the energy from the output signal is reflected back to the tube and is used to modulate the electron beam, resulting in high efficiency and improved performance. The reflex klystrons are used in various applications such as microwave ovens, radar systems, communication systems, and particle oscillators. So the characteristics of this reflex klystron is it is a resonant cavity which is made up of two cylindrical cavities. The cavities are separated by a small gap which is called as drift space. So here the electron beam is an electron gun is used for producing the electron beam, and they produce a narrow high velocity electron beam that is directed towards the resonant cavity. So the electrons are focused by magnetic fields and are made to pass through the drift space. So next concept is called bunching. So when the electrons are passes through the drift space, that is the spacing between the two cavities, they are affected by the accelerating electric field produced by the resonant cavity. So this causes electrons to bunch together and forming group of bunches, which is called as bunching process. So next is the amplification part. The bunches of electrons that passes through the resonant cavity interact with the electric field, causing the field to be amplified. So the amplified electric field then interacts with the next bunch of electrons, resulting in further amplification. So in this way, the reflex klystron is useful for providing the amplification of microwave signals. Next is another important application is oscillation. So oscillation, how it produces is the interaction between the electron beam and the resonant cavity can cause the cavity to oscillate at a frequency determined by the dimensions of the cavity. So this produces microwave signal, can be used for various applications such as in radar and also in communication systems. So now we see the working principle part. So working principle, a reflex klystron involves the interaction of an electron beam with the resonant cavity to generate and amplify the microwave signals. In reflex klystron, we have only a single cavity, and in klystron amplifier we have two cavities. And here the single cavity, which is used as buncher cavity and also the catcher cavity. So here the electron gun produces electrons. So this narrow beam of electrons, when interact with RF field, they produce oscillations. These oscillations are connected are bunched in during forward direction, and in the reverse direction they will be collected as RF output through the cavity. So the electron beam formation. So the electron beam is produced by the electron gun and directed towards the resonant cavity. So next is bunching process. When they propagate through drift space between the electron gun and the resonant cavity, voltage generated at the gap A, and which is responsible to produce bunching of electrons or velocity modulation of the electron beam. So we have a repeller in the device which is at a distance L, and the repeller voltage can be adjusted to receive all the electrons at the same time on the positive peak of the RF cycle. Thus, The velocity modulated electrons are bunched together and lost their kinetic energy when they encounter the positive peak of the cavity or a field. When power delivered by the electrons is equal to the power loss in the cavity, microwave oscillation is started. So next is amplification and oscillation. So this happens when the interaction between the electron beam and the resonant cavity can cause the cavity to oscillate at a frequency which is determined by the dimensions of the cavity. So this produces a microwave signals that can be amplified by the interaction between the cavity and the electron beam. So the amplified signal is then output through a waveguide or other output device. And next is the reflected energy. A portion of energy from the output signal is reflected back into the tube and is used to produce or modulate the electron beam. So this results in higher efficiency and improved performance. So the overall effect of this process is to produce a stable high frequency microwave signal that can be used for various applications such as in radar and also the communication systems. So in the diagram we can see there is an interaction between the resonant cavity. So this interaction causes the electrons to get energy which results in the increasing of velocity of the electrons. So it has the advantages of reflex klystron as having high frequency stability because they operate at higher frequencies with excellent stability which make useful in application where they require precise and stable signals. And this reflex klystron produces higher power output or higher microwave signals which is suitable for applications which require high power output such as radar and communication system. And not only that, the reflex klystrons are compact size when compared to other microwave tubes, which makes them ideal for use in applications where the space is limited. And low noise. Reflex klystron generate very low noise levels which makes them suitable for use in applications that require high signal to noise ratios such as communication systems, and they have long lifespan and can operate for many thousands of hours without requiring any maintenance, which makes them cost effective choice for many applications. Overall, we can conclude the reflex klystrons high efficiency stability, high power output, compact size, low noise and long lifespan make it versatile and a reliable option for a wide range of microwave applications. And coming to the disadvantages, so even though the reflex klystron has so many advantages, it has some disadvantages also. So they have required high voltage for to operate, so this makes expensive and pose a safety risk, and limited frequency range, and they offer limited power control, and they are sensitivity to temperature changes, and because the sensitivity of reflex klystron the performance affected with respect to temperature, so this limit the stability and reliability in some applications. And next is the complexity. Reflex klystrons are relatively complex device when compared to some other microwave tubes, which make them difficult to design, manufacture and maintain. So application part, the reflection klystrons are used in radar receivers, local oscillator in microwave receivers, portable microwave links, pump oscillator for parametric amplifier, which is another type of microwave active device. So we see the performance characteristics. It produces frequency between 2 to 200 gigahertz and its power is 10 microwatts to 2.5 watts. Theoretical efficiency is 22.78%. Practical efficiency is 10 to 20 percentage, and its tuning range is 5 gigahertz at 2 watts and 30 gigahertz at 10 microwatts. So assessment question. The Klystron tube is used in Klystron amplifier belong to the answer A, linear beam, which is a single cavity Klystron tube that operates as an oscillator by using reflector electrode after the cavity. The answer is reflex Klystron. Thank you.